Well, ladies and gentlemen, welcome to tonight's lecture. I'm Alistair Robertson. I've just stepped down as the Pro Vice-Chancellor for Research at the University, and it's my honour to be the Master of Ceremonies tonight. First of all, I want to start off with recognising the traditional owners. It's the tradition of the University of Western Australia to acknowledge that this university is situated on Noongar land, and that Noongar people remain the spiritual and cultural custodians of their land and continue to practice their values, languages, beliefs and knowledge. Tonight's lecture is part of the Inquiring Minds lecture series, which started in 2012. This new series, co-sponsored by the UWA Institute of Advanced Studies, the UWA Research Services Office and the Centre for Software Practice here at the University. Its goal is to provide a forum where the exciting research that's undertaken by UWA researchers is communicated to and shared with the community at large. These free lectures are also filmed and will be available on the Inquiring Minds website and YouTube shortly after each lecture. Other Inquiring Minds lectures will be offered this year on a wide variety of topics, from the history of emotions to the ocean's evolution and beyond. We are immensely proud of the research at UWA, and we're delighted to share this with you. And it's absolutely my pleasure tonight to introduce tonight's speaker. Professor Carlos Duarte has a joint appointment as the Director of the UWA Oceans Institute here in Perth, and he's also a research professor with the Spanish National Research Council at the Mediterranean Institute for Advanced Studies in Mallorca. Professor Duarte's research focuses on understanding the effects of global change in aquatic ecosystems. He's published more than 500 papers and 2 books. In 2010, he led the Malaspina expedition, a Spanish circumnavigation expedition that sailed the world's oceans to examine the impacts of global change on marine ecosystems and marine biodiversity. In 2009, he was appointed member of the Scientific Council of the European Research Council, the highest level scientific committee at the European level. He's received many honours for his work, including the National Science Award of Spain in 2007, the King James I Award for Research on Environmental Protection in 2009. In 2009 he also received the Silver Medal Cross of Merit from the Guardia Civil in Spain for his service to environmental protection. And in 2011 Professor Duarte received the Prix d'Excellence, the highest honour awarded by the International Council for the Exploration of the Sea. He's been leading EU-funded projects in the Arctic since 2007 and has taken and led 10 cruises to the Arctic in that time. He's also just been invited to brief the US President Obama, on the future changes that are going to occur in the Arctic. So it's an honour for us and a pleasure for me personally to invite Carlos to talk to us tonight about abrupt climate change in the Arctic and why we should care. Thank you, Carlos.
Good evening. Thank you, Alistair, for the introduction. And thank you all for coming tonight. And tonight I will try to make the point that the Arctic is a lot closer to Australia than you might think. And I will do that through walk you through some evidence of the abrupt changes that are taking place in the Arctic, also elaborating on why those changes fall within what the UN considers dangerous climate change, what are the global risks of those changes spreading in the rest of the planet, and also through the social consequences and the paradoxes of the changes in the Arctic also delivering significant opportunities as well as they are bringing about risks. I published with colleagues in Cambridge University and Tromsø University in Norway a paper last year about abrupt climate change in the Arctic in the journal Nature Climate Change. And there we contended that semantic arguments about the definition of tipping points are distracting attention from the causes and impact of climate change in the Arctic. And we argued that the UN Convention for the Climate, whose goal is to avoid dangerous climate change, have actually come to failure, because in the Arctic the changes that are happening fall within the definition of what dangerous climate change is. And rather than engaging in semantic discussions, we now need to address how are we going to manage and evaluate and assess the risks of dangerous climate change and avoid those from spreading elsewhere in the planet. Now, the Arctic region is one of the regions of the planet that is warming fastest, and the rate of warming is about 4 centigrades per decade, which is 2 to 3 times faster than the global rates. And the warming will continue to accelerate according to all projections along the 21st century. And I will show results later on that will show that the projections have actually come short of anticipating what is actually occurring in the Arctic, and the changes are much faster than the models were projecting only 7 years ago. Now, I'd like to introduce some concepts that are important to consider the concept of dangerous climate change and abrupt change, and those are the concepts of thresholds and tipping points. So most often we assume that changes in nature in response to a pressure are smooth and reversible, so that if we do have a pressure like global warming impacting on the extent of sea ice, as the planet warms, then we will have a reduction in the extent of sea ice along a smooth trajectory, but when the planet will cool again, then we will have ice growth to the previous extent on a symmetric trajectory. Now, this is all very nice, but most often the responses of natural systems to pressures do not conform to that concept, but they show abrupt changes. And these changes depend on the relationship between the elements that intervene in defining the system that is being studied. So most often we are actually encountering responses of this type, where following a smooth response to a pressure, then we have an abrupt change and a very rapid change into a new status for the system. And we need to understand and manage abrupt change in the Arctic, but also in many other elements of the Earth system. And that requires that we first take approaches that acknowledge that Earth systems are complex and they are inherently nonlinear and display complex behavior. And nonlinear behavior is characterized by shifts in the status of a system between often two alternative states. And those shifts between those alternative states happen once particular thresholds or tipping point are trespassed. And once those tipping points have been exceeded, it is often the case, not always, but often the case, that recovery is very slow, even though the pressure can be released, but the trajectory of recovery is not symmetric to the trajectory of impact, and sometimes there's actually no return. And those thresholds sometimes can be points of no return, and even provided given sufficient time, then we might have a system returning to the previous state, but that return might be so slow that in practical terms might be reversible, because it might take thousands of years, tens of thousands of years, or even millennia, hundreds of millennia to achieve. Because really ecological thresholds are the points in the system whereby the response of a system to a pressure, and this can be the sea ice extent in the Arctic, to a pressure like warming of the climate, makes an abrupt jump between two modes, stable mode A and a stable mode B, and then I will indicate what those stable modes are in the case of the Arctic. So there is an abrupt change, and that happens once a threshold is trespassed. And that tipping point then defines the shift of the system from the mode A of functioning to the mode B, And when the pressure, which in this case is global warming, is relaxed, then the growth of the sea ice extent and the recovery might be slower than the other trajectory. And you might need to cool the system far more than required to have the sea ice extent return, much more than it was required to warm it for that change to occur. So the thresholds and the tipping points are not located in the same position of the pressure when the system is flipping from state A to B than when you want to achieve the opposite result. Now, in the Arctic, and I'm referring particularly to the Arctic Ocean, that qualitative element that differentiates between two alternative states is actually the sea ice in the summer. So the two obvious states of the Arctic are an Arctic Ocean covered by significant extents of ice in the summer, or an open Arctic Ocean that is blue and is functioning like any other ocean during the summer. And we exactly know what that tipping point is, because we know what the temperature for the ice to thaw is, right? So it's very easy to predict what this tipping point may be in the case of the Arctic. And if we look now at what is happening in the Arctic in terms of sea ice, this representation here shows the extent of sea ice in the Arctic from 1979 to present. That's actually the value of yesterday. And it shows it as an anomaly. The anomaly is the deviation of the sea ice extent relative to the mean value between 1979 and 2008. And what we can see in this figure is that the mean extent of sea ice corrected for this mean value has been declining steadily, and in the last 5 years has been declining faster. And in fact, in 2007, in the summer of 2007, the extent of sea ice was about almost 3 million square kilometers below the mean value for summer. And this event was trespassed in 2012, where a new record of minimum sea ice in the summer was reached. So when this event happened in 2012, that was really surprising to everyone. All scientists were surprised by this, and even today our models cannot really reproduce what happened in 2007. There was a lot of discussion in the literature as to whether the Arctic system had gone across a tipping point or not. And really the important fact is not what happened in 2007, but now that we are trying to understand how we can be alerted to the proximity of tipping points in many systems, including the stock market or the global economy. Now we understand that there are leading indicators of a system about to flip, and those leading indicators are an increase in the variance. So whatever we are monitoring, being the stock market, being the extent of sea ice, or being any other property in a system, starts to jiggle and oscillate greatly, and that signals the proximity of a tipping point. So the important element in this figure is not that there was an abrupt minimum in 2007, but it was that if we look at the variance, the variability of sea ice, if we look at over time, so it goes up and down, there was an excursion in 1996. That was an early warning that there were some changes coming up, but the baseline returned to the same values. But then what happened in 2007 is the variability of the extent of sea ice increased greatly, and even though declined subsequently, it did not return to the former baseline. So there's been an increase in variability in the extent of sea ice relative to the mean values, and that variability is what is signaling that we are very close to a tipping point in the Arctic. And the outcome of that tipping point will be an Arctic that will be devoid of ice during the summer, except for some very small locations. And I'm talking about sea ice, not the Greenland ice cap. So now how this accommodates to model projections for sea ice in the Arctic. So the blue line, the thick blue line, shows the model projections that were published with the IPCC report in 2007. And the IPCC, the International Panel for Climate Change, that assesses the evidence for climate change in the planet, has to work with peer-reviewed literature, and there's a deadline which sets the literature that can be included in the report. So even though the report was published and approved in November 2007, the literature that was used in producing the report was up to March 2007, right? And it did not include the summer of 2007 when this change occurred. So the models that were formulated in 2007 were predicting that sea ice will be declining smoothly, and by the end of the 21st century, in the height of the summer, the minimum amount of sea ice remaining will be about 2 million square kilometers. And the thin blue lines indicate the uncertainty bounds about the models. And the red line that you see there is the actual record of the minimum extent of sea ice between 1980 and present. And what you see is that already in 2007, the model predictions were wrong, because the observed extent of sea ice already fell well below the bounds of uncertainty, and now we are already at 3.5 million square kilometers of minimum ice extent in the summer, which is what was predicted to occur in 2080. So the future has accelerated, and we're seeing an Arctic now that was predicted only in 2007 to be the Arctic that we will be experiencing in 2080. So everything is shrinking, and every year that has elapsed since 2007, the model prediction of when the Arctic will be free of ice is advanced by almost a decade. And right now, in 2012, we are forecasting the Arctic to be devoid of ice in the summer in the ocean in 2015. So that's only 2 years from now, whereas in 2007 we were predicting that there will be still significant spans of ice in the Arctic at the end of the century. Now, this is not something that occupies only scientists that might be alarmist or so on. These are satellite records, but the US Navy is very much interested in this because it affects global geopolitics, it affects global navigation, and they were predicting only in 2010 that the Arctic will be open for maritime transport in 2013. Now again, they're looking at 2015. So it's not only a matter of interest to the research community and those that may have particular opinions about climate change. It's actually realities that are used in planning strategies by organizations like the US Navy. Okay, so the Arctic is important not only because of the sea ice in the Arctic, but an important paper by one of my co-authors in the paper that I started quoting, Tim Lenton, recognized that the Earth system contains about 14 elements that he named tipping elements, which are triggers that, if disturbed, are able to cause significant changes in the Earth system as a whole. And there is a representation here taken from that paper of where those 14 tipping elements are. And if we look at the Arctic region, which is very small in terms of the Earth's surface that it occupies, it contains 6 of the 14 tipping elements. Those are the loss of Arctic sea ice, those are the melting of the Greenland ice sheet, the dieback of the boreal forest in the northern latitudes, the Atlantic deep water formation that is fundamental as a motor for climatic regulation in Earth, the possible occurrence of an ozone hole, and that was published in 2008, and the ozone hole has been first observed last year. So this was a possibility then, but now is again a reality. The dieback of the forest that we've mentioned, the thaw of the permafrost, the loss of tundra, and also now we can add some other elements like the role of biota becoming a significant source of carbon dioxide to the atmosphere, the melting of the methane hydrates that can send significant amounts of methane to the atmosphere. That is a very powerful greenhouse gas, 20 times more powerful than carbon dioxide by unit weight. And also the burning of peat deposits in the Nordic boreal regions. 2 summers ago, there were a series of fires near Moscow that were actually the peat deposits in fire. And once those peat deposits will be sufficiently dry to catch fire in the north, the whole north of Canada and the whole Siberia, there'll be no power on Earth to stop that pit from burning. So those are significant triggers that can bring about important changes to the Earth system and that we need to watch and monitor very carefully. So a little bit of insight into some of these triggers of change. The Greenland ice sheet contains enough ice to raise the level of the ocean by 7 meters, if it was entirely melted. Now, this is not going to happen by 2050 or 2100. The estimates indicate that the Greenland ice sheet will probably melt, but it will likely take about 300 years for this ice sheet to melt. Although recent results, again, are superseding our predictions. And what I'm showing here are results released by NASA in the northern summer last year that showed that only in 4 days in July, the extent of Greenland that was experiencing surface melting, which is the red area, passed from being about 30% of the surface of Greenland, which is sort of the regular observation for summer in the Arctic, to actually affecting 98% of the surface of Greenland. And that was a major event of melting in Greenland, which probably can be explained by aligning several perfect storms. So it's not just one factor, it's several factors that align and then lead to a major event like a widespread melting of the surface of the Greenland ice cap in 2012. So you can see that a number of events are happening that are signals that something is going on and we need to be alert and possibly react to these changes. Now, those changes on the Greenland ice cap, as I indicated, are very relevant for global sea level. They're very relevant for our coastlines in Australia. And if we look, for instance, at what the consequences will be in Boston, so this figure shows projections of sea level rise with future warming. If only warming occurs, that will be this line going to 2100, or if there is rapid ice melt, particularly in Greenland. So the brackets of uncertainty are huge, and more recent revisions of those projections are opening the brackets even wider to even consider 1 meter of sea level rise by the end of the century. Much of what will be the outcome of these broad brackets of uncertainty depends on how the Greenland ice sheet responds to changes in the Arctic. The Southern Ocean and the Antarctica is a little bit of a less of a concern because it's on a closer balance, but the Arctic is definitely experiencing significant ice loss. Now, it's not only the sea ice on the Arctic that is melting, it's not only the ice cap in Greenland, but also across the land in the Arctic, the permafrost, that is the frozen ground, is melting, and that is leading to a process called thermokarst formation, where a landscape that used to be dry converts in an aquatic landscape full of ponds, rivers, and water everywhere. And this is increasing the discharge of fresh water to the ocean significantly. The discharge of fresh water has increased by 30 to 40% to the Arctic, and the Arctic Ocean has now become an estuary, holding 7,000 cubic kilometers of water more than it used to have, fresh water, more than it used to have only 10 years ago. And something else is melting, and those are methane hydrates. And methane hydrates are a form of frozen methane, which are methane molecules. There is a photo there of how it looks. It's a little bit like a gel, a muddy gel-like structure, and those are molecules of methane that are encapsulated in ice, in water, frozen. And this, again, is vulnerable to thawing and melting, and then the methane being released. Those are huge deposits of methane that are largely resting in the continental shelves of the Arctic. And if we look at the size of those deposits, which are mostly located in the shallow continental shelves and coastal areas of the Arctic, the amount of that reservoir is within the size of all the fossil fuel deposits and reservoirs known to date. So it's a huge amount of carbon sitting as methane in this area. And if that is released and is released abruptly, then we can have a kick to the whole global climatic system that will probably alter greatly the climatic mode of Earth. So we need to be monitoring what happens with these methane hydrates and how stable they are. Unfortunately, most of the deposits are in the Siberian coast. That is kept inaccessible to most scientists. To access the Siberian coast for research, you need to be on board a Russian research vessel, and no access to researchers, international researchers, is still granted unless you charter a Russian research vessel. So there's been very little and limited effort in looking at the changes in methane emissions from the Siberian shelf. But really what happens is that when the sea level was lower than it is today, then those methane hydrates were mostly lying in the soils, in the coastal areas, and as sea level rise increased and also sea temperature increased, then those methane deposits have been flooded by warmer water, and they're more prone to melt and release that methane into the atmosphere, which will have a significant consequence for the heat budget of the planet and the climatic regimes that we might experience in the future. Then one other element of trigger that you might be familiar with through either scientific literature or even Hollywood, with a very much exaggerated version of this trigger, is the global thermohaline circulation. That is really also popularized as the global heat conveyor belt, and it's a system by which surface water in the ocean sinks to form deep water, and that deep water circulates slowly across the depth of the ocean basins and eventually resurfaces in the Pacific to the surface and then returns again through the surface. The whole cycle of that conveyor belt is about 800 years that it takes to complete that cycle, but the motor that propels that conveyor belt is located in the south of Greenland. And in fact, it was already known to the Vikings, which in their sagas had a whirlpool located in the south of Greenland, exactly where we know the site of deep water formation is. So if the flux of fresh water to the Arctic increases and the Arctic meltwater flows to the Atlantic through the Fram Strait, which is the strait between Greenland and the Svalbard Islands located around here, then that water flows around the Greenland current and eventually meets warm Atlantic water that, because it's so much warmer, is less dense, and that means that the surface cold water sinks, and it sinks into the depth of the oceans with sufficient velocity to even resuspend the sediment at 3 meters depth. And that is a huge volume of water that is sinking in the south of Greenland and then flows around the ocean and keeps that conveyor belt running. And that, for instance, is the motor of the current regimes, the Gulf Stream that keeps the north part of Europe warm and sufficiently warm to be pleasant to live on. Now, if that conveyor belt is to stop, and it can stop when the amount of fresh water being discharged is sufficient to add buoyancy to that water and slow down or even prevent altogether the sinking, then that mechanism to redistribute heat will stop. And the prediction of what will happen if that mechanism stops is that there will be a cooling of the northern regions of the Earth, with temperatures going down up to 4 and 6 degrees below current, and that the tropical regions will warm up significantly. And that's because what this current does, it takes heat from the tropical regions and shifts it to the northern latitudes in the north of Europe. But this is not happening in isolation. There's been speculation that this can lead to a glaciation in the northern hemisphere, paradoxically propelled by warming. But what this cartoon is not considering is that this is happening at the same time that we have warming. So really what you need to consider is that the consequence of that mechanism shutting down will be that you need to add those two pictures, which is the projections of how global temperature will change and the projection of warming rates. In fact, what will happen is that the Earth will warm more uniformly. So the Arctic will warm less rapidly, and the tropical regions and the subtropical regions will warm faster. So that's the net result of that mechanism, because ocean currents do not either add or remove heat. they just redistribute heat. And as I indicated, we are being met with more surprises, again, recently. And in fact, this was 2011, not 2012, when an unprecedented decline of Arctic ocean over the Arctic was reported. And what this figure shows is the normal time trends of ozone concentration over the Arctic, which are these blue here, the purple, the orange, and the red line here is the seasonality of ozone over Antarctica, right? So when ocean declines below this level and enters this gray area, then we call it an ozone hole. And we've had an ozone hole for a number of decades now over the Southern Ocean, but we have never observed an ozone hole over the Arctic. In 2011, which is this red line, the amount of ozone over the Arctic reached the values that we call an ozone hole. And that was observed for the first time. And even though we're still puzzled, or the research community is puzzled to try to explain this is most likely explained by changes in the climate regime of the Arctic prompted by the rapid climate change in the Arctic region. So that's possibly a consequence of, among possibly other drivers, changes in climate over the Arctic. And also one of the consequences is that the mode of atmospheric circulation over the Arctic is flipped, and now during the winter there are jets of very cold air, moist air coming to Europe and North America, and again paradoxically we have colder winters and with more heavy snow in the northern hemisphere as a result of warming of the Arctic than we had before. But that again was anticipated and predicted, but it's just happening faster than we thought it would. It's not only the physical elements and forces of the Earth system that are changing, also there are significant impacts on biota, and the icon, much to the despair of Inuits, is the polar bear, and there's concern about the future of the polar bear in the Arctic. But that's not the only species of the Arctic that is probably in critical stage or endangered eventually with climate change. We conducted recently a review of all the evidence for impacts of climate change on biota in the Arctic, and we had a total of 51 documented significant impacts of climate change on Arctic marine biota. You can see that most came from the Bering Sea and the Chukchi Sea, and from the area between Greenland and the Svalbard and the Norwegian coast, and that's because those are the two areas that are most studied and where research effort is most intense. Because whereas Antarctica has been a territory for research and peace since the 1960s, the Arctic was the chessboard of the Cold War. And whereas we had research bases in the Southern Ocean, in the Arctic we had stations looking at whether missiles with nuclear weapons were being exchanged between Russia and North America. And it was a territory that was blocked for research. So for every 100 papers, scientific papers on Antarctica, there's only one on the Arctic. It is very close to nations with major research efforts like the US or some of European nations, but yet is really lagging behind in research and understanding compared to any other area in the world. So there are, for instance, 3 different types of species: walruses or polar bears or seals, that depend critically on ice as their habitat, to rest, to reproduce, to hunt, and if the ice goes away, those animals are gone with the ice. And there was a paper recently, not particularly focused on the Arctic, but that modeled the consequences of a simultaneous change in climate, but also habitat, and deemed this a deadly anthropogenic cocktail. And basically what this figure here shows, that's the probability of survival. 1 means all survive, 0 the species goes extinct. This is the rate of climate change, and this is the % of habitat loss. So in the Arctic we have both forces simultaneously. We have climate change forcing the system, and at the same time, as a consequence of climate change, the ice, which is the habitat, is shrinking, and that brings great likelihood of extinction to some of these species that depend on the ice as critical habitat. We have also recently published that just last week a series of 2 papers that showed that the plankton community of the Arctic Ocean can also be a trigger mechanism, because if warming exceeds 5 degrees, then the plankton community becomes a source of carbon dioxide, because photosynthetic rates that remove CO2 decline, but respiration rates of the community that generate CO2 and release CO2 increase, and there will be a flip from the Arctic plankton community being a sink of CO2 to being a source of CO2 to the atmosphere when seawater temperature exceeds 5 degrees. These here are experimental results from large mesocosm experiments, and these here are results showing the same threshold at 5 degrees for this flip to occur from our series of 10 cruises that we've done in the Arctic since 2007. And there's one more force acting in the Arctic, and that force you might not have heard about much, but it's something called the global distillation process. And we know that most of the pollutants that are mobile in the Earth system are produced and released and used in the Northern Hemisphere. And many of those pollutants enter a global redistribution, and those pollutants tend to deposit in surfaces that are cold. And in surfaces that are warm, those pollutants are emitted to the atmosphere if they are volatile or semi-volatile. So what we have is a process of grasshopping of pollutants that eventually accumulate in the Arctic and accumulate in Arctic ice, in Greenland, and in glaciers. And there are heavy loads of pollutants everywhere in the Arctic. Most of them coming from latitudes outside the Arctic, but some of them generated by industrial activities in the Arctic, like coal mining, was a major source of heavy metals to the Arctic ecosystem. And there was a very important court case in Norway in 1978 that led to the closing of the coal mines in Norway because of their role in releasing very large amounts of heavy metals that had led to high contamination of all the food web. Belugas and Inuit are the 2 organisms most contaminated on Earth. So we have a situation where ice melting has the potential to set a cascade of abrupt changes in motion, a domino effect that is starting to occur in the Arctic. And that nonlinear tipping element has been the change in the sea ice in the Arctic. And there are many of these changes that are starting to occur, or for which there's a risk that they might start to be set in motion in the next years. I mentioned that pollutant levels were high in belugas, they're high in seals, they're high in polar bears, but they're also high in people. And the levels of persistent organic pollutants on human milk from Inuit women are so high that the World Health Organization recommends Inuit women not to breastfeed their child because they will be poisoning them, right? And that impact, you can see that the levels are 10 times to 100 times higher in Inuit women than they are in other Caucasian population in the Arctic. That's because the Inuit still are very much connected to the food web. And if their food web and their food sources is heavily polluted, they become heavily polluted themselves because they continue to eat seals and other animals that are exposed to this pollution. And Inuit people are seeing how their traditions and culture are being disrupted by climate change and the loss of ice. And that is not just a matter of culture, it's that in the past years there's been a number of accidents where Inuit people have lost their lives because their traditional routes of transport in the winter across ice zones that they have been using first with the sleds, now with the ski-doos, for decades and centuries now have become unreliable, and they sink in the ice and they die. Now, we're not looking at a very large number of human lives. There's only about 100,000 Inuit in the whole of the Arctic, but still it has significant culture. It's an old culture, 4,000 years old, that is suffering the impacts of climate change, and yet they don't even have a nation from which they can have a voice in the UN and alert the rest of the world to what's happening to them. So I've been working with an Inuit leader called Aqualuk Ligne, and he was the president until 2 years ago of the Inuit Circumpolar Convention, which is an NGO by which Inuits have a voice. and he is deeply troubled and worried about the fate of his people and the fate of his culture. That's just a poem from Aqualook, but I won't read it because I don't have time. One other consequence, and that draws on the loss of cultural values of Inuit, loss of traditions, but also on the pollutant levels, because it is known that high pollutant levels led to mental disorder and behavioral disorders, is that there is a very high suicidal rate among the young Inuit population. This figure shows suicide rates per 100,000 people between Inuit people. Those three lines in the top are Inuit people of different regions of the Arctic, and those are Caucasian populations that live in the Arctic. So the suicidal rates are 30 to 50 times higher than those for the Caucasian populations among the Inuit. And it's definitely a very troubled culture, and a culture that is suffering greatly from the changes in their environment. But changes in the Arctic are also bringing about opportunities. And those opportunities are basically access to resources. So the amount of fishing pressure on the Arctic is mounting by the year. That also includes my fellow countrymen, Spanish, that are notorious for going north and north with the fishing boats to take on the new fishery resources that are becoming now available. So this figure here shows a protected area in the Arctic in the Barents Sea in Norway. Between Norway, the north of Norway, that will be 76 degrees north, and the Svalbard Island, this will be 81 degrees north. And what you see here is this corner, and you see those dots of line that are in the border of the protected area. Those are the fishing vessels, just at the edge of the protected area, pecking the fish that escape between the boundaries that they don't know about of this protected area. So the amount of fishing in the Arctic is growing and increasing, and that it's providing good livelihoods for some people, but it can also enhance some of the impacts. There's also a rush of gas and oil extraction in the Arctic. Those are the areas designated for and licensed for gas and oil in the coast of Norway. And these here show the areas. This is the end of Norway here. This is Siberia in Russia. These are the areas that are being licensed for hydrocarbon extraction in the Arctic. And the licenses are being applied farther and farther offshore from these regions. So we have a resource bloom going on in the Arctic, as we've seen also in Western Australia, and that also includes mining, because the Arctic is very rich on ferromanganese nodules that are being now mined from the seafloor of the Russian continental shelf. It is an important area for gold extraction in Russia, in Canada, and also in Alaska for gold. And right now, Canada, the Arctic in Canada is becoming a very significant source of diamonds and is now producing 12 to 50% of the whole diamond production in the world. And in Greenland, the number of licenses are growing rapidly. And one of my colleagues works for the Greenlandic government in environmental assessing of the license applications. And then he supplied some data that there are more than 200 applications for mining licenses, and 40% of those come from Australian-based mining companies. So there's a first connection between Australia and the Arctic. Beyond that we see in our beaches, with sea level rise already having contributions from things happening in the Arctic. And that connection comes even closer because every year for the last 4 years there's been a workshop in the UNIC lab on exploration targeting. So that is, those mining companies are looking at training people and engaging with exploration of mineral resources in the Arctic, and some of that is happening just here in this room, right, every 4 years. There's many opportunities there. The local government in Greenland is looking at this as an opportunity to first become independent from Denmark, for which they will have to compensate them with a very large sum of money for Danish investments in Greenland, and it's very hard to turn around from that opportunity. So it is a difficult balance. You see opportunities to develop resources, increase the livelihoods of people, but at the same time you perceive the risks. It's very hard to turn the back to those opportunities. And that is a paradox that we need to live on. There are risks that also come with opportunities, and how we balance those is fundamental to everyone in this planet. And the last element of change that I wanted to indicate is the opening of the navigation routes around the Arctic. So this figure shows what a ship that is developing something produced, for instance, in China, had to do to deliver that product to Norway. And this is what that ship will have to do once the Arctic is available for navigation. So there is about a third of the transit, and the gains in terms of cost of global transport are huge. Plus also, if you look at this route, it's going through some of the most risky areas in the world in terms of pirate attacks, right? So you do not only shorten the transit, but it's also safer in terms of the risks of pirate attacks. Now, this paper was just published a few weeks ago in the Proceedings of the National Academy of Sciences, and it shows projections of what will be the viable shipping routes across the Arctic in 2006 to 2015. So that will be mostly through the Siberian Shelf. But between 2040 and 2059, it will be possible basically to take straight routes, either through the Northwest Passage or through the Siberian Shelf or straight across the North Pole, because there'll be no ice there in the winter. And yet, this is 2014, but the Russian government has established a new company called Rosatom-Flot, where the 15 largest nuclear icebreakers in the world that are owned by and operated by Russia have been assembled to guarantee that ships can already go across the Arctic with the escort of these icebreakers. And this figure here shows a very impressive photo of one of the icebreakers called Yamal cutting through ice in the Arctic. And their argument is that the business of navigation through the Arctic is so important that we shouldn't leave it to the caprices of climate. We should open those navigation routes. And they started to do that in 2010. And they've also moved ships through the Arctic in the middle of the winter. This is a Swedish icebreaker called Thor Viking that is being crossed through the middle of the Arctic by Yamal in the winter of 2010. Okay, so one last consequence of the changes in the Arctic is that the geopolitics are coming into place. And in 2007, just when the rapid melting of the Arctic was realized, a research submarine from Russia planted a Russian flag to 4,000 meters depth just here, just next to the North Pole. And that action came with a claim of all this territory for Russia. And the area here, the dotted area, is the area that is recognized as being Russian economic exclusive waters by the UN Law of the Sea, but they have claimed all of that. And that triggered a domino effect from the other countries to have similar claims. And there's been meetings between what is called the Arctic Five, which are Denmark, because of Greenland, Russia, Canada, the US, and I'm missing one. Yes. Yes. To apportion themselves those international waters between themselves. So there's been meetings that were nominally about safety, search and rescue in Greenland, so that since there will be boating in and navigation in the Arctic, somebody needs to be responsible for rescue and search in the case of accidents. So those meetings have been nominally about search and rescue, but the person, for instance, who led the U.S. delegation to those meetings was Secretary of State Hillary Clinton. So it was not really technicalities that were being discussed. And in apportioning the area of the Arctic that each nation took responsibility for in terms of search and rescue, there was also indications that those were the areas that they will claim as their economic exclusive zone eventually. And out of those meetings, that proposition came about. So this area in the border shows the recognized international limits of the economic exclusive zones, and the areas here show what the claims are. So basically, the international waters are gone, and I think that this is just the international waters that are left, when the international waters were all of this. And of course, that needs to be approved by the UN and the UN Law of the Sea, but the US, for instance, has not ratified the UN Law of the Sea, and that is becoming a little bit a de facto action. And that not only is affecting geopolitics in the Arctic, but as a consequence of this, many nations that cannot have claims in the Arctic have made claims in the Southern Ocean, in Antarctica. One of those nations has been the UK, that has announced that they're going to initiate exploration for oil and gas and minerals in British territory, which falls within the Antarctic Treaty, and that was immediately followed by Argentina, making similar announcement, that then was followed by Chile, making similar announcements, and then China has argued that since the international waters belong to all the population, they should have an apportioning of the international waters that is proportional to their weight to the global population. So that is becoming very messy, and surprisingly, most of these discrepancies have been arranged between the neighbors, and possibly the most significant still litigations are in place between Canada and the US. And the US indicates that the Northwest Passage should be considered an international passage, and that means that every ship is free to pass without any kind of control other than traffic control, whereas Canada argues that the Northwest Passage is internal waters. The difference is that if they are internal waters, then Canada will have the right to place a pilot in every ship that goes to that route, and the cost of placing a pilot in a mid-sized merchant ship is about $50,000 to $70,000. So that is a big source of income, and one that is behind that litigation between the US and Canada will probably be resolved soon. There were similar litigations between Norway and Russia, but those have been just settled recently. So if we come to the beginning, what is dangerous climate change? So implicitly, the UN defined dangerous climate change as changes in the climate system that have complied to these 5 elements or reasons. Risks to unique and threatened systems, risk of losing unique ecological and social systems. The second one is risk of extreme weather events. The third one is that the impacts will spread beyond the area where the climate is changing. The fourth one is that there will be possibly aggregated damages. And the fifth one is that there will be risks of large-scale discontinuities. That means tipping points, abrupt changes, and more threshold and rapid change. And I'm not going to walk through that, but what I list on the next column is evidence that all of those reasons for concern are already met in the Arctic. So we already have dangerous climate change happening in the Arctic, and yet we haven't formulated a strategy on how to cope with this situation. We keep entangled in discussions about whether is it anthropogenic change, has the ice recovered or not, and while those discussions go on, the changes in the Arctic accelerate, and the risks that these changes can trigger and release mechanisms of change that will affect us all are increasing. So we need to start considering how we're going to manage this situation. And that's really about facing change. And that paper is about something else, but I argued that environmental sciences and scientists are living in a sort of Neverland, Peter Pan syndrome, where we expect things to remain perpetually unchanged. And we deny that the world is in change and has been in change always, and probably it's changing faster now than it was in the past. And the challenge for us all is to acknowledge, like the character Wendy in Peter Pan, that we need to face change and grow and address the changes, not back up from it, address them. And Paul Valery said in a more nicely way, and he said that the problem with our times is that the future is no longer what it used to be. So we are entering an uncharted territory, and we need to prepare for futures which we have not experienced before. The dialogue between scientists, policymakers, social scientists, governments, NGOs, citizens groups, Cultures like the Inuit will be fundamental in being able to manage unknown futures. So I'd like to leave you with the Arctic paradox, which is that the Arctic nations are responsible for 26% of the global emissions of greenhouse gases in 2009 and include 3 of the top 10 nations in per capita emissions of carbon dioxide. If we were not looking only at the Arctic, we would be including Australia there as well. And global warming is largely due, and there's solid evidence of that despite the continuous noise in the media, is largely due to human emissions of greenhouse gases, and is triggering ice loss in the Arctic and a change of changes that come with the loss of ice that are potentially dangerous and can spread and release mechanisms that can affect globally everyone. Now, the Arctic nations, and I organize, isn't here, but I helped organize a meeting in the Arctic that had a political section that was attended by ministers from the different nations, and all of them, every one of them, acknowledged to be concerned about the situation, acknowledged that the rapid changes in the Arctic were due to climate change and were due to the emissions of carbon dioxide. None of the government representatives from the 8 nations with territory in the Arctic argue otherwise. But while acknowledging that, they also indicated there are huge opportunities to derive wealth and benefit from accessing the resources in the Arctic. And they said that they are not going to take steps unilaterally because that will disadvantage their industry. And that argument sounds familiar, right? So nobody is willing to take a step and say, I'm going to move away from the emissions to reduce the pressure on the Arctic and the climatic system of the planet. They will say, I'll do that if everyone else follows. But nobody's taking the lead, no one is taking the first step. And in contrast, countries like Norway are reopening coal mines in the Arctic, coal that they don't need, because Norway has already all the power they need. Why are they opening coal mines in the Arctic, in the Svalbard, that were actually closed because of the impacts it had on the emission of heavy metals to the region? They are opening them to be assertive of their territorial sovereignty on the territory, to be present and active, and be an important geopolitical source. But any of those motions will trigger a symmetric move by another nation. And in fact, everybody is now reopening coal mines in the Arctic, which is surprising. So how do we manage Arctic ecosystems near tipping points? So we need to increase our observational effort to particularly focus on those 6 to 8 tipping mechanisms, tipping elements, that if they are set in motion, they can really send wave of change across the entire planet. So we need to monitor those closely, and that needs international cooperation, particularly to access the methane hydrates deposits in Siberia and be examining what's going on with the stability of those. We need to evaluate the risks and the economic cost of abrupt changes, and maybe reserve some income from emerging opportunities to mitigate the risks that those opportunities also generate. We need also to manage Arctic ecosystems to build resistance and resilience to thresholds and tipping points, and again, maybe allocate some of the benefits that are derived from the use of the new opportunities to that goal. And we need to develop dialogues between scientists that are examining tipping points and Arctic managers and policymakers, and basically really promote international cooperation so that we can balance those opportunities from which really no one is going to walk away, with responsible management of the risks. Thank you all, and as an announcement, this lecture will be available to view or download as a podcast at this address. Thank you.